On August 12th, the sky unfolds in three acts that normally belong to three different nights. Before sunrise, 6 planets occupy the same broad arc of the sky. By evening, the moon's shadow races from the Arctic toward Europe and erases the Sunday above Greenland, Iceland, and Spain. After darkness returns for the ordinary reason, Earth enters a river of comet dust, and the Perseid meteor shower reaches its peak under a moonless sky, and somewhere between those real events, the internet insists that gravity switches off. Depending on which post you see, Earth supposedly loses gravity for 6 seconds, 7 seconds, or exactly 7.3 seconds. A secret NASA operation called Project Anchor is said to be preparing underground shelters. Objects allegedly rise into the air, millions of people fall, and the world is never the same. The story comes with a precise time, a huge budget, casualty estimates, and language that sounds scientific enough to frighten anyone who sees it while scrolling at 2 in the morning. That story is false. NASA has directly denied it. There is no evidence that Project Anchor exists. Eclipses cannot turn gravity off, and nothing in accepted physics allows Earth to lose its gravitational field for a few convenient seconds. In fact, the most widely shared version gives 1433 UTC as the moment of the supposed gravity blackout. The real eclipse does not even begin anywhere on Earth until more than an hour later. But do not make the opposite mistake and dismiss August 12th as just another viral date. The fake story attached itself to this day because the real sky is already extraordinary enough. This is not simply a solar eclipse. It is a sequence of genuine celestial events compressed into roughly 24 hours, a widely advertised 6-planet parade, a total solar eclipse, crossing some of the most dramatic landscapes on Earth, and the peak of the year's most famous meteor shower under almost ideal lunar conditions. No, these objects do not all gather in one tiny patch of sky. The planets do not pull Earth apart, and nobody floats. The reality is more subtle, more beautiful, and in many ways more unsettling than the rumor. For a brief moment, millions of people watch daylight fail. The atmosphere cools. Familiar colors drain from the landscape. Bright planets may emerge around a black Sunday. Animals may behave as if evening has arrived. Then sunlight returns. The planet parade continues along its separate geometry, and comet dust begins writing fast lines across the night. To understand why this particular day matters, we follow it from before dawn to after midnight, and separate what is truly visible from what has been exaggerated. We also need to understand why people who have already stood inside the shadow of the moon often describe totality as one of the most powerful experiences of their lives. They do not speak that way about a 99% eclipse. They speak that way about the final 1%. On August 12, 2026, the first trace of the partial eclipse appears at 1534 UTC. The first total phase begins at 1658 UTC. Greatest eclipse arrives at about 1746 UTC. And the last place on Earth leaves the partial shadow shortly before 2000 UTC. Those times describe the global movement of the event, not what one observer sees from one location. The shadow is traveling, and every town beneath it receives a different appointment with darkness. The path begins in the high north, close to the edge of the Arctic. It crosses remote parts of northern Russia, moves over the Arctic Ocean and northeastern Greenland, touches western Iceland, runs for thousands of kilometers across the Atlantic, and finally reaches the Iberian Peninsula. Most of the route lies above ocean, ice, and sparsely populated land. Taken as a whole, the track links radically different worlds: Arctic settlements, glaciers, volcanic islands, open ocean, historic European cities, and millions of people following the shadow online, from places where totality never arrives. Near the point of greatest eclipse, west of Iceland, totality can last about 2 minutes and 18 seconds. That is the maximum Reykjavik enters totality at roughly 5:48 in the afternoon local time. Farther along the track, observers receive different durations and very different versions of the same darkness. In the Arctic, the shadow passes over ice and isolated coastlines. In Iceland, it arrives in late afternoon in Spain, where the track ends near sunset. Most observers receive closer to 1 or 2 minutes. Spain may offer the most cinematic view of the eclipse because totality arrives with the Sunday already low in the western sky. In the northwest, the Sunday stands roughly 12 degrees above the horizon, from parts of the Mediterranean coast and islands. It may hang only a few degrees high mountains. Buildings, trees, haze, or a narrow bank of cloud can decide whether an observer sees the Black Sunday or misses it completely. But that is only one face of the event. Greenland may frame totality above ice and fjords. Iceland may place the corona over a volcanic Atlantic landscape farther south. A clear western horizon can show the dark disk and white corona inside the colors of evening, just above hills, skylines, cliffs, or Mediterranean water. The same shadow therefore produces several visual worlds before disappearing from Earth. For every community under the central path, totality is both global and intensely local. Total solar eclipses occur somewhere on Earth every year or two, yet any particular location may wait generations or centuries. Spain has waited more than a century for a comparable event. Across Greenland and Iceland, the route carries the same alignment over completely different landscapes and weather systems. The importance of August 12th does not belong to one country. It comes from a moving shadow that the world can follow from the Arctic to the edge of the Mediterranean. To see why totality is so rare from one place, imagine the moon's shadow not as a continent, size blanket, but as a moving spot. A total solar eclipse occurs somewhere on Earth roughly every year or two, but the darkest central shadow touches only a narrow corridor. Most locations wait centuries between direct hits. Outside that corridor, the moon covers only part of the Sunday, sometimes almost all of it, but the decisive transformation never arrives. The geometry begins with an extraordinary coincidence of scale. The Sunday is about 400 times wider than the moon, but it is also about 400 times farther away. From Earth, their apparent sizes are therefore similar. Because the moon's orbit is not a perfect circle, its apparent diameter changes. Sometimes it looks too small to cover the Sunday and leaves a bright ring. On August 12th, it appears large enough to hide the solar surface completely along the central path. The alignment has a formal name, syzygy. Every solar eclipse is also a new moon, but most new moons pass slightly above or below the Sunday because the moon's orbit is tilted. Only at the right crossing point does its shadow touch Earth. The broad outer penumbra produces a partial eclipse. The small, dark umbra produces totality. This is why 99% is not close enough. Even a tiny uncovered piece of the Sunday is intensely bright. At 90% coverage, daylight looks unusual but remains daylight at 99%. The air may cool and the light may become thin and metallic. Yet that final solar sliver still overwhelms the corona. The human eye adapts. The landscape remains visible. The sky does not become the deep, unnatural twilight of totality. Then the last bright valley on the moon's edge closes. The change is not proportional. It is a threshold. One moment there is a dangerous fragment of direct sunlight. The next, the Sunday's brilliant surface is gone. The corona appears around a black center. The horizon may glow in all directions because areas beyond the umbra are still receiving daylight. Bright stars and planets can emerge. People who calmly discussed camera settings seconds earlier often shout, laugh, or cry without planning to. Accounts from the 2017 and 2020 4 North American eclipses repeat the same pattern. Experienced adults say photographs failed to prepare them. Teachers regret not convincing students to travel the final distance into totality. People who watched 98 or 99% believed they had seen almost the same event, while those inside the central shadow insist the difference was complete. The partial phase is an astronomical observation. Totality feels like the rules of the environment have changed. The final minutes begin quietly as the solar crescent narrows, ordinary shadows sharpen and distort. Light passing through small gaps between leaves projects hundreds of tiny crescent suns onto walls and pavement. Colors lose warmth because the remaining sunlight comes from a thin edge of the solar disk. The temperature can fall. A breeze may rise as the shadow changes the local balance of warm and cool air. Very close to totality, faint rippling bands may move across pale surfaces. These shadow bands are created when the last thin beam of sunlight is disturbed by turbulence in Earth's atmosphere. Then points of light break apart along the edge of the moon. Mountains and valleys on the lunar surface allow the Sunday to shine through in separated beads. They are called Bailey's beads. Own brilliant point may remain beside the growing corona, producing the diamond ring effect. This is the last warning to anyone still using unprotected eyes inside the path of totality, and only after the bright solar surface has vanished completely, eclipse glasses can come off outside the path they stay on. During totality, the moon itself does not become a visible black rock with surface detail. It appears as an absence, a dark circle cut into the sky around it. The corona extends in pale streamers. This outer atmosphere of the Sunday is always present, but the solar surface is so bright that the corona normally disappears in its glare. Totality creates a natural instrument more perfect in scale than any object humans could place in the sky. The shape of the corona changes with solar activity and magnetic fields. It may show long equatorial streamers, polar brushes, loops, or asymmetric structures. Red prominences can sometimes be seen along the edge, where enormous arcs of glowing plasma rise above the hidden surface. Every one of those features is larger than it looks. A small red point visible from Earth may be a structure many times the size of our planet. The eclipse also changes the sky. Venus may become obvious, while Mercury and Jupiter may appear close to the hidden Sunday if conditions are clear, but observers have less than 2 minutes, and the corona dominates attention. Then the sequence reverses. A bright bead returns. The second diamond ring flashes. Glasses must go back on immediately. The corona vanishes in the glare. Daylight rebuilds. Birds resume daytime behavior, and the ordinary world returns before the partial phase has even ended. The experience changes continuously along the path. In the high Arctic, clouds, sea ice, and access are the main challenges. In Greenland, remote coastlines may see the shadow arrive over fjords. In Iceland, Atlantic weather can transform within minutes. At the European sunset end of the track, the western horizon becomes critical. A hill that seems harmless at noon can hide a low Sunday, while coastal haze can erase the corona. The shadow crosses the final populated section of its route in only a few minutes. Some observers see totality well before sunset. Others watch the partially eclipsed Sunday descend below the horizon, still missing a piece of itself. These differences are not side notes. They are what make one global eclipse feel like many separate events. The broad partial eclipse zone reaches millions of people beyond the path of totality. Dublin receives about 94% coverage, London around 91%, and Paris more than 90%. Across Europe and northwestern Africa, the Sunday becomes a narrow crescent near evening. Parts of Canada and the northern United States receive a smaller partial event, while much of the world lies outside the visibility zone entirely. Official broadcasts, observatories, news organizations, and online viewers turn a narrow moving shadow into a global shared event. And the eclipse is only the middle act of August 12th, hours before the moon covers the Sunday. Headlines promise a rare parade of 6 planets. The 6 usually listed are Mercury, Mars, Jupiter, Uranus, Saturn, and Neptune. From Earth, they occupy a broad arc along the morning sky. But the phrase planetary alignment creates an image that is more dramatic than the observation. The planets are not arranged nose to tail in a straight line through space. They are scattered across enormous distances and different parts of their orbits. They look broadly aligned because the major planets orbit the Sunday in nearly the same flat plane from our position inside that plane. Their paths project onto a band across the sky called the ecliptic. Planets always remain near that band, so several can appear along the same arc. Planet parade is not a formal scientific category with one universal definition. It is a popular name for seeing several planets in the sky during the same general period. Such groupings are enjoyable, but they are not gravitationally dangerous and are not as rare as many viral graphics suggest. There is another important correction. 6 planets being above the horizon does not mean 6 bright worlds are obvious to the naked eye. Mars and Saturn are the easier targets. Mercury stays low and competes with twilight. Jupiter is extremely close to the Sunday's direction on this date, making ordinary observation difficult. Uranus is faint, and Neptune is even fainter. Both generally require binoculars or a telescope, a dark sky, and an accurate chart. So if someone walks outside before sunrise and does not see 6 glowing dots arranged like beads on a necklace, nothing has gone wrong. The viral illustration has simply compressed a huge arc of sky and removed the atmosphere, horizon, sunlight, and limits of human vision. The real connection between the parade and the eclipse is more interesting. Jupiter's closeness to the Sunday makes it hard to see at dawn, but totality briefly removes the Sunday's direct glare. A planet hidden by daylight can suddenly emerge beside the black disk. The eclipse does not pull Jupiter into position. For a few minutes, it removes the bright background that normally conceals the planet. Venus adds another twist. It is not one of the 6 planets usually counted in the morning parade because it is positioned in the evening sky, yet Venus is so bright that it may be the easiest planet to notice during the eclipse. The day's most visible planet is therefore the one omitted from the viral 6-planet list. After the eclipse, the third act begins. Earth enters the densest part of the Perseid meteor stream as the night of August 12th turns into August 13th. The Perseids return every year because Earth crosses a trail of debris left by Comet Swift-Tuttle. The comet follows a long orbit around the Sunday, returning roughly every 133 years. Each passage sheds dust and small fragments along its path. The stream remains in space, and Earth moves through it on schedule. Most Perseid particles are no larger than grains of sand. They do not glow because they are burning like charcoal. They strike the upper atmosphere at roughly 60 kilometers per second, compressing and heating the air in front of them. The air and vaporized material emit light, creating a fast streak that may last less than a second. Brighter fragments can leave persistent trains or explode as fireballs. The shower takes its name from Perseus because the streaks appear to radiate from that constellation. They are not actually launched by the stars of Perseus' perspective. Makes parallel meteor paths seem to converge in the distance, just as railway tracks appear to meet at the horizon. The International Meteor Organization places the May 2020 6 maximum in the early hours of August 13th Universal Time, with broader elevated activity surrounding it. That means the best local window changes with longitude. The shower is active for weeks, so observers do not need one exact minute. Under a clear, truly dark sky, rates can approach dozens of meteors per HR and perhaps near the often quoted figure of 100 under ideal conditions. Real viewers usually see fewer because of light pollution, clouds, blocked horizons, limited patience, and the fact that the radiant may not yet be high. This year has one enormous advantage: no moonlight. A solar eclipse can happen only at new moon, when the moon lies in the Sunday's direction and its night side faces Earth. Once the eclipse Sunday sets, the moon sets with it. The night is left naturally dark. The Perseid peak therefore arrives, without a bright moon washing out the faint streaks. That is why astronomers describe the viewing conditions as excellent. The three events are not simultaneous. The planet parade comes before dawn, the eclipse later in the day, and the meteor peak after dark. From a suitably placed part of the totality region, a determined observer could follow all three, but never as the crowded tableau shown in viral posters cooled a bright Perseid cross the corona during totality. In principle, yes. Meteors are already active, and the darkened sky could reveal an unusually bright streak. But totality lasts less than 2.5 minutes, while the best meteor viewing requires a much longer watch. Capturing both in one frame would be extraordinary precisely because it is unlikely. Three predictable cycles simply overlap planetary orbits, create the morning arc, the moon creates the eclipse, and Earth's crossing of Swift. Tuttle's debris creates the Perseids. Their shared date is many celestial clocks running at once, not a supernatural convergence. That brings us back to gravity. The viral Project Anchor story claims that 2 gravitational waves from black holes intersect Earth and cancel gravity for several seconds. It claims NASA calculated this with suspiciously precise confidence, allocated tens of billions of dollars to secret shelters, and selected special people to survive. None of those details has a credible document, scientific paper, budget record, or named research team behind it. The story works because it combines a real institution, a real astronomical date, and fabricated precision. 7 seconds sounds more research than a vague warning. A time written in UTC sounds official. A project name sounds classified. A casualty range feels as if someone ran a model. The reader receives enough numbers to stop asking where the numbers came from. NASA's answer is much simpler. Earth's surface gravity is determined primarily by Earth's mass. To make the planet lose that gravity, Earth would have to lose the mass of its core, mantle, crust, oceans, water, and atmosphere. An eclipse does not remove any of them. The moon blocks light. It does not block gravity. The Sunday and moon do exert gravitational forces on Earth. We observe their combined effect most clearly in the tides. At new moon and full moon, the Sunday, Earth, and moon are aligned in ways that strengthen tidal ranges, creating spring tides. That happens every month. The forces are measured, predictable, and included in astronomical calculations. They do not cancel Earth's attraction on people, buildings, or oceans. Gravity is also not a beam that one object can shield. Putting the moon in front of the Sunday does not place Earth in a gravitational shadow. The moon, Earth, and everything on Earth continue moving under gravity before, during, and after the eclipse. Gravitational waves are real, but the rumor uses the term as decoration. These waves are tiny distortions in space-time produced by accelerating massive objects, such as merging black holes. Instruments like LIGO detect changes far smaller than an atomic nucleus across kilometer. Long detectors. A wave powerful enough to throw people 20 meters into the air would not arrive as a secret 7-second inconvenience. It would represent physics and energy on an entirely different catastrophic scale, and observatories around the world would not quietly miss it. The rumors imagine motion is wrong as well. If downward gravity somehow vanished, objects would not automatically acquire a powerful upward acceleration. Removing a downward force is not the same as firing every person and car toward the sky. The neat timeline in which everything rises to a specific height and then falls is cinematic writing, not a calculation. Astronauts provide another common source of confusion. They appear weightless in orbit not because gravity disappears, but because they and their spacecraft are continuously falling around Earth together. Gravity at the altitude of the International Space Station remains strong. Orbital weightlessness is free fall, not a gravity blackout. So nothing special happens at 1433 UTC. Gravity does not hesitate. Oceans do not lift away. Planes do not drop. The greatest danger associated with August 12th is far more ordinary. People damaging their eyes by looking at the Sunday without proper protection or creating traffic hazards while rushing toward an unobstructed horizon. Why then does the false story survive after NASA denies it? Because eclipses already feel like violations of common sense. The Sunday is the most reliable object in human experience. It rises, lights the world, and cannot normally be stared at. When it becomes a black circle surrounded by white fire, the emotional brain reacts before the scientific brain explains. For most of human history, people did not possess global maps showing the umbra to the second. Eclipses could signal the death of rulers, the anger of gods, the arrival of war, or the temporary consumption of the Sunday by a creature. Different cultures developed different stories, but many shared the same instinct. An interruption in the sky must mean an interruption on Earth. Modern calculation changes the interpretation, not the sensation. Astronomers can map an eclipse centuries in advance, yet totality still causes crowds to gasp. We know the Sunday is not being destroyed. We know the light returns. Our bodies still feel the temperature fall and watch afternoon become night. Eclipses have also been tools of science. During the total eclipse of 1919, astronomers measured the apparent displacement of stars near the Sunday, providing famous early support for Einstein's prediction that gravity bends light. Today, natural totality still offers valuable views of the inner corona. NASA's scientific program for August 12th includes high-altitude observations. One planned platform is a WB-57 aircraft, capable of rising above much of the atmosphere and following the shadow while cameras record the corona in several wavelengths. Moving with the umbra can extend the useful observing time beyond what a stationary team receives on the ground. In those few minutes, the instruments are designed to collect thousands of images of structures that change rapidly around the Sunday. The scientific campaign also includes balloon teams in Spain and Iceland. Their instruments are designed to study how the atmosphere responds when sunlight suddenly drops, tracking temperature, ozone, and other changes as the shadow passes. Previous eclipse experiments show that atmospheric chemistry and local conditions respond even during a short total phase. The shadow is brief, but it is large and cold enough to become a moving natural experiment. European missions add another layer. Solar Orbiter observes the Sunday from space. Proba 3 uses two spacecraft flying in precise formation, with one blocking the Sunday for the other, to create artificial eclipses lasting far longer than natural totality. The comparison is striking. Humans are now learning to manufacture the same alignment that ancient societies feared. The corona matters because it is the source region of the solar wind and the stage for magnetic activity that can influence space weather near Earth. Its temperature reaches millions of degrees, far hotter than the visible surface below. A long-standing scientific puzzle. Totality exposes fine structures near the Sunday that are difficult to isolate through Earth's bright sky. The eclipse also offers a large-scale experiment in life and behavior. Birds may begin evening routines. Insects can become active. Some animals grow quiet, while others respond as if night has arrived unexpectedly. The effect depends on species, habitat, season, and how dark the location becomes. It is not one universal reaction, but it reveals how deeply sunlight controls biological clocks. For human observers, preparation is simple but non-negotiable. During every partial phase, use eclipse glasses or a handheld solar viewer that meets the appropriate international safety standard and comes from a reliable source. Ordinary sunglasses are not enough, no matter how dark they appear. Smoked glass, exposed film, compact discs, and improvised filters are not safe substitutes. Check glasses for scratches, punctures, or loose filters. Put them on before looking toward the Sunday, then look away before removing them. Children need supervision because the danger does not hurt immediately. The retina has no pain receptors to warn you while intense sunlight is causing injury. Binoculars, cameras, and telescopes require filters mounted securely over the front of the instrument. Never look through magnifying optics while wearing only Eclipse glasses. The lenses concentrate solar energy. A pinhole projector is a safe indirect alternative. Only observers fully inside the path of totality may look without a solar filter, and only during the short interval when the Sunday's bright surface is completely hidden. If any bright solar crescent remains, protection stays on in a city with a 99.9% partial eclipse. There is no safe naked eye phase. For viewers near the sunset end of the totality path, safety also means planning the landscape. Find an open western horizon before the day of the event. Do not assume a rooftop beach or mountain viewpoint remains accessible. Large crowds and traffic are likely near popular viewing areas. Arriving late and stopping on a road is more dangerous than missing the view. If clouds cover the Sunday, the eclipse still changes the environment. The light falls, temperature may drop, and the horizon may darken as the umbra passes. But clouds can hide the corona completely. Eclipse chasers understand this harsh bargain. Years of planning can be defeated by one small cloud at the wrong altitude. Those outside the visibility zone can follow official live streams from sites along the entire track. A broadcast cannot reproduce the full sensory experience, but it can show the corona, the approaching shadow, and reactions from people beneath it. It also allows a global audience to compare an Arctic passage, Iceland's afternoon darkness, and the low sunset totality at the European end of the route. The most compelling way to watch is not to spend the entire 2 minutes adjusting a camera. Set a wide camera running in advance if you want the memory of the changing landscape, then leave it alone. Look at the horizon. Notice the temperature and the crowd find Venus. Watch the last bead vanish. Totality is too short to experience through a menu screen. And after the Sunday returns, do not assume the day is finished. Let the sky become fully dark. Move away from city lights. Give your eyes at least 20 minutes to adapt, and look across a wide area rather than directly at Perseids. Meteors can appear anywhere. A reclining position makes a long watch easier. No telescope is needed. A telescope shows too small a portion of sky. The contrast between the eclipse and the meteor shower is almost philosophical. The eclipse demands a narrow place and an exact minute. Move a few dozen kilometers outside the path and the central experience disappears. The Perseids ask for patience rather than precision. They can be seen across much of the world over many nights, one unpredictable streak at a time. The planet parade sits between them. Its geometry lasts for days, but the visibility of individual planets depends on twilight, equipment, and latitude online. The three events become one poster. In reality, each teaches a different way of reading the sky. The eclipse teaches that location can matter more than percentage. The parade teaches that apparent alignment is not physical closeness. The meteor shower teaches that tiny debris can reveal the path of a comet across centuries. The gravity rumor teaches something about us. When real astronomy becomes spectacular, false certainty rushes in to occupy the gaps. That may be the most important reason to pay attention to August 12th. Not because the world ends, but because the day shows how easily wonder can split in two directions. One direction leads to observation, measurement, maps, orbital mechanics, and a deeper sense of scale. The other leads to secret projects, invented numbers, and fear packaged as revelation. The universe does not need the fake version. Before dawn, 6 planets occupy a sweeping arc, even if only some are easy to see later. The moon's umbra follows a track more than 8,000 kilometers long from the Arctic toward the Mediterranean. Near Iceland, totality lasts for more than 2 minutes. The central path places communities directly beneath the route of a Black Sunday, while millions elsewhere can follow the passage in real time. After nightfall, Earth reaches a stream of ancient comet dust beneath a new moon's sky gravity, remains exactly where it has always been. The day's most extraordinary image is not people floating upward. It is millions of people standing firmly on the ground, looking up together as the most familiar object in their world becomes unrecognizable. For a minute or two, the clockwork of the solar system becomes visible. The moon's orbit draws a moving line across Earth. The planets reveal the flat architecture of the system around the Sunday. Comet debris marks Earth's path through space. 3 different cosmic cycles overlap. not because they are sending a warning, but because the universe is always moving, and on this date, we happen to notice several gears at once. The shadow's route ends near the Mediterranean, where the last diamond ring marks the return of ordinary daylight. The false countdown reaches 0, and gravity never changes. Hours later, the Perseids continue across the moonless sky after most eclipse viewers have gone to sleep. The date moves from calculation into human experience. For anyone who watches carefully, August 12th offers something more valuable than a prophecy, proof that reality, accurately understood, is still capable of overwhelming us.